I'm going to teach today, this is Algebra 2. Okay, this is Algebra 2, and I'm going to teach part of Chapter 7. Okay, Chapter 7. So for a lot of you, this is enrichment, and for some of you, you've seen it before. So could be either. Could be review, or it could be seeing something that you haven't seen before. So this is, I call this algebra fractions, but that's not its official name. So I call this algebra fractions. Okay. But its official name is called rational expressions. So the word rational, often in math, is how we officially refer to fractions. So the algebra just means there's an x in it. So for example, you would have something like 1 over 2 plus 2x plus 4 plus 3 over 7x. You see that you have x's in the denominators, and they're fractions. So they look like fractions. You have some x's in the denominators, or even if you had them in the numerators. So I refer to these as algebra fractions, but they're really called rational expressions. Okay, so the first type we're going to talk about today are the ones that say simplify or they say multiply. In our Big Ideas textbook, this is section 7.3. So this is 7.3 in Big Ideas. Sounds good. So I have some letters to remind myself of the order that I need to do problems in. So for these, I call this FFC. So anytime it says simplify or multiply, I write down FFC, and then it reminds me what order to do things in. So the first F stands for factor. The second F also stands for factor. And the C stands for cancel. Now, one of my students the other day, last week, was telling me, hey, Miss Nichols, C could stand for cross out. So I thought, okay, that's good. The key is that you have to factor before you cancel. Now, these two factors are basically, we're going to factor the top and we're going to factor the bottom. Later on, you're going to see a longer list in adding and subtracting fractions, algebra fractions, or rational expressions. And when we do that, we need 6 steps, and some of the steps are going to include FFC. So that's why we're going to just get started here with this. So let me show you how it works. Basically, you have example 1, and you have x squared minus 9 in the numerator, and in the denominator you have x squared minus 2x plus 3. And the instructions say to simplify. So probably would be better if I put example 1 over here, and I wrote the instructions. So it says simplify. Okay, so simplify. So I look at this and I think, okay, FFC. So FFC, I see the algebra fractions, I need to take care of it. Now what lots of people do is they'll see first. So they'll cancel things out first. They'll cancel out the x squareds. That's not allowed. So it's important that you do it in the order that it says. So the first thing we're going to do is factor the numerator, and then we're going to factor the denominator, and then we're going to cancel. We can do this sideways, or we can do this up and down. So x squared minus 9. Think of what kind of factoring that is. Our class hasn't done that since first semester. We haven't done too much factoring. So this officially is called a difference of squares. So we abbreviate that as a dose. And remember how we did those? We were thinking of two numbers that multiply to be x squared, or two letters, and two numbers that multiply to be 3 times 3. And then the ones that are in the front go in the front of the parentheses. And then the 3's that are in the back, they go in the back of the parentheses. And then in order for us to not have a middle term, OS stood for opposite signs. So one's plus, one's minus, it doesn't matter which one. Now in the denominator, we have one that we have to factor. Different people have different names for it. I was calling it check. And then you're multiplying to get the 3. You're multiplying to get the x squared. That's what I called it at the beginning of the year. It doesn't really have an official name. It's just called factor the trinomial. So x squared is x times x. 3 is 3 times 1, or 1 times 3. This one doesn't have too many possibilities. But if this last number, this blue number right here, was say a 36, then you could try 36 and 1, 2 and 18, 6 and 6. There'd be a lot of different possibilities that we need to try. But in this case, it's just the 3. If you had me for Algebra 1, I call it box factoring. But most of you did not have me for Algebra 1. Okay, so x and x, and then 3 and 1, 3 and 1. And then the check means that I have to get this middle term using these numbers. So 3x and 1x somehow have to get negative 2x. So I'm going to choose the sign. So I'm going to pick the minus in front of the 3, and then I need a plus for the 1. So that's factoring the denominator. So a trinomial, it's called a trinomial because there's 3 terms. The top is a difference of squares. So we factored each. So we did the f, we did the f. So the only thing left is now the c. So the c means you can cross out things that match. So you can cross out the x minus 3 and the x minus 3 because they match. You have to have one from the top and one from the bottom. And then the only thing that's left on the top is an x plus 3, and what's left on the bottom is an x plus 1. And then that's the final answer. So that is example 1. That's an example of simplify. Now multiply has the same rules. So multiply still means FFC if you see the algebra fractions. So the FFC is something that you can write down so that you can remember it when it comes up in a future problem when you're not in this chapter. So here's another example. So this is example 2, and this one says multiply. 2x minus 8 times x squared minus 25 divided by x squared minus 6x plus 5. So if I see the multiply, I do FFC. If I see the word simplify with an algebra fraction, I do FFC. So FFC means you need to factor all the numerators. You need to factor all the denominators. In adding and subtracting, it's going to be a little bit different because we're supposed to factor the denominator in step 2, and then later in step 6 is when we finally factor the numerator or the top. So we do that much later in this. So that'll be another video. Okay, so for this one, I have to identify which one do I want to factor. So you have 2 that are trinomials because there's 3 terms. So see if you can locate those. So the trinomials would be the top left, this one, and then the other trinomial would be this one. So I was calling those check problems. You're trying to think of numbers to get x squared. And you're trying to think of numbers to get 4, so say 2 and 2, or 4 and 1. But I have to check to get this middle term. So I'm supposed to get negative 3x, not as my guesses, but in the final result. So that first one, the top here, we'll go to the top here. So x and x. And then you have to decide, should I pick 2 and 2? Should I pick 4 and 1? 2 and 2. Can I think of any way those would make 3? I don't think so. How about the 4 and the 1? With the 4 and the 1, is there any way I could get negative 3? So if I have a 4 and a 1, how would my signs work out? So if I have a minus on the 4 and a plus on the 1, then that would turn out to work. Let's do the other trinomial. So the other trinomial is this bottom one on the right side. Same thing, check. Oh, this one's nice. 5. How can you multiply to get 5? Only 5 and 1, so that's perfect. And then x and x. And if the letter's different, or if there's a 3x squared in the front, if there's an a, then we kind of have to think about this a little bit differently. But these are the first most basic ones. Complicated, but basic. Okay. Okay, so x and x, the only way is 5 and 1. I can't think of anything else. How am I going to get a negative 6x? So that's my goal, my check, or my goal. I need to get that with 5 and 1. So what are my signs? Positive, negative, negative, positive, negative, negative, positive, positive. So to get a negative 6, I'm going to need a negative and a negative. And that's negative 6, not negative 6x, but if you actually multiplied it out, these two would give you the negative 6x. Okay, so do you see one that's like our x squared minus 9? So if you look at this x squared minus 9 right here, which I call the dose, do you think that the top, this one, top right, or the bottom left, which one looks like a dose? The blue one up here has an x squared. This one has an x squared. 25 is a number that's like a 9. So let's try that out. Okay, so let me erase all these blue highlights. I've erased the x too. Okay, so erase the blue highlight. Oops, I deleted the x squared as well. Okay, so let's try to look at this one, the top right. So the two letters that multiplied by x squared is x times x, and to multiply to 25 would be 5 times 5. Okay, and that is a dose. Okay, a dose, a difference of squares. I got this from another teacher. He used to call them DOSs, and then some student on my board saw a dose and said, wasn't paying attention actually, in Algebra 1 quite a few years ago, and said, oh, it's a dose. Why do you have dose written on the board? I was like, dose? I don't have dose written on the board. And we found it. And through that interaction, it was nice because dose reminds us that there's two of each. There's two terms originally. It does have to have a minus in the middle. And then OS means my answer has opposite signs. So everything is kind of compacted in that little abbreviation. So x and x, 5 and 5. And this one, I'll do this in red just so you could see it better. But basically, this top becomes the new top. And then dose, meaning opposite signs. One's a plus and one's a minus. It doesn't matter which way. You can have the minus and then the plus also. Okay, so there's only one left that we haven't factored, which is the denominator on the left side. Now there's no x squared, so I'm not going to do it the same way. It's not a dose. So you have to think, how could we do this? Now last week when I taught this to part of my class, some of the students were taking state testing, but some of the other students were here. They figured it out. So they called it something that I really wouldn't have called it, but I like the name. So they called it distributing. I don't usually call it distributing, so I'll write what the official name is that I think of it as. But I like the idea of distributing. It's where you have something in the front, and it distributes, and then it gets you this 2x minus 8. So that's what we're trying to look for. Okay, so what I call it is I call it GCF factoring. So I call this GCF. And GCF stands for greatest common factor. So we did that back in the very beginning of Algebra 2. Okay, so 2x minus 8. You have to think, do I know a number or a letter that goes into 2x and in 8? 8 doesn't have a number, so you can't put it doesn't have a letter, so you can't put the letter in the front, but you can put the 2. 2 goes into 2 and 2 goes into 8 evenly. Then you have to figure out, okay, what's left? So what can I multiply 2 by to get 2x? And the answer is x. And multiply 2 to get something else. How am I going to make 2 turn into an 8? So that'd be a 4. Okay, now you have to look overall at what you have. So let me kind of put a line between this. So basically we have what's under the line. And I just did the FF being factor, factor. So I did the F, I did the F. Now I need to figure out to do the C. So what does C stand for? F stands for factor. What's C stand for? Okay, so C stands for cancel. And then what you have to cancel is anything from the top can cancel with anything from the bottom as long as they match. So this x plus 1 here does not cancel with x minus 1 because they have to match perfectly. Okay, x minus 4 cancels with x minus 4. And then x minus 5 cancels with x minus 5. And diagonal is okay. It's just in this one, there is no diagonal cancellation. And then you multiply straight across. Okay, so you multiply straight across, which is the way you usually multiply fractions. So straight across. Let me remind you, say you had 1/2 times 3/7. When you're working out fractions, you multiply across the top and across the bottom. So that would be 3/14. Okay, so we don't need a common denominator when we're multiplying fractions. Okay, so on the numerator, we have x plus 1. Anything else in the numerator? Looks like x plus 5. So you multiply those two. You don't have to FOIL them out. You do not have to distribute. Usually they're just left the way they are like that. And then 2x minus 1. Now, if you were taking a multiple choice test, perhaps they're multiplied out. So if they're multiplied out, then you could multiply them out by distributing and then match it to a multiple choice test. But that's only if they want you to. Usually people leave them factored. Okay, and our last example for right now is a division. Okay, so a division. I think we're going to do 2 more examples. Okay, so a division. So a division, how do you divide fractions? So try to think, how did you used to divide fractions when you were in middle school? How did you divide fractions? We flipped one, called the reciprocal. So which one did we flip? The first one, or did we flip the second one? Or did we flip both of them? So the answer is you just flip the second one. So you flip the second one. Okay, also called the multiply by the reciprocal, and then you multiply straight across. So for division, we're going to have a new word in the front. We're going to call it flip FFC instead of just FFC. Okay, so let me give you a problem like this one. Okay, so this one, we have x squared plus 2x minus 8 over x squared minus 25 divided by 2x plus 8 over x squared minus 4x minus 5. Okay, so for division, our goal is flip FFC. So which one do you flip? You flip the one after the division sign, and then you do need to change it to a multiplication sign. So you flip the second one. First one does not flip. The official name for flip is reciprocal. So reciprocal flips these over. Now, do we cancel yet? So cancel is the last thing in the list. You don't. So you write the initials so you remember the order. So don't cancel yet because you have to do that in the last step. That's also true for adding and subtracting. The canceling is always done in the last step. So we did the flipping, check, and now we need to FF. So FF means factor. So the numerator factors. So it's a good idea to pause and see if you could factor all of these yourself. So check, XX. So try to think of your numbers. How do you get 8? 8 and 1, 4 and 2. Which one are going to check to give you a positive 2x? That would be 4 and 2. To get a positive 2, I'm going to need a positive 4 and a minus 2. Bottom one is a what? So it's a dose. So I need 2 things that multiply to be x squared, 2 things that multiply to be 25. So x and x, 25 would be 5 and 5. OS, positive, negative. Okay, the numerator right here is also a check. And probably in Algebra 1, your teacher probably had a better name for it. It could have been a butterfly. I call it a box. Different teachers call it different things. Reverse FOIL is something that teachers call it too. I don't usually call things FOIL, so to me, I don't use that word, but definitely one of those words might remind you how to do it. So if you do need more help, it'd be good to find a video on factoring trinomials if you wanted to find out maybe another way and some extra practice. You can also email me or put in the comments that you need extra practice on that, and I'll make a video. Okay, so minus 5 plus 1 in order to get that negative 4x in the middle. And then the denominator is a GCF. So again, there's no letter next to the 8. So there's no x here. So that means you don't put an x in the front. So that means no x in the front. So when you do something like this, you don't put an x in the front here if there's no x in any of the terms. So just a 2. Think of what you need to distribute to get to x plus 8. In this case, it's x. And then 2 times what equals 8 is 2 plus 4, is x plus 4. Then you can cancel. So now I've done the f's. So FF is factor the top, factor the bottom. So I've done my 2 f's. And now I need to do my C. So C stands for cancel or cross out. X plus 4, they cross out. Anything else cross out? See if you can find it. X minus 5, they cross out. Looks like nothing else crosses out. X minus 2 is on the top. X plus 1 is at the top. And x plus 5 is at the bottom. And this 2 would be the most common thing that people would lose. Okay, so lost. Often I write that on my tests when students take them and then I'm correcting the tests. I'll put little arrows and put lost because somebody will forgot to put it. So for us, let's not put lost, let's not lose it, and let's put the 2 in the denominator. So this is the answer. You can multiply it out, but only if it tells you to. I'm going to do a half example. I'm not going to do this one as a full example. So say you have 2x. Won't do it 2x. Let's say you have x squared minus 9 over x squared minus 4x plus 3, and it says divided by x squared minus 2x minus 3. What do you do when it says divide and there's no fraction? So what do I do in the second one? How am I supposed to flip FFC if there's no fraction to flip? So remember, you can put something underneath it. So what do you put underneath if there's nothing there? What do you put underneath if there's nothing there? So that would be a 1. So I want to do x squared minus 9. X squared minus 4x plus 3 times, and then you flip it, and now your 1 goes at the top. I guess we might as well finish this one since we're almost done. So try to think of how it factors. Maybe pause the video so that you can factor at a normal speed and not my math teacher speed. Okay, so line, 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 line. This is a dose. This one's a check. Think of your numbers, think of your letters, check the middle. So those are not part of my guesses. Same thing here, check. Line, 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 line. See if you can figure it out. So pause the video, work it out yourself, and then you could see and check if you get the same answer for me. The same answer as me. So 3 and 3, plus and minus, XX, 3, 3. Minus, minus if I want a minus 4. x3, x1, minus, plus. See if anything cancels. And remember, you're not going to remember this stuff if you don't practice it. So you can practice. That would be excellent. I think I'm going to try to put a link to a Google Doc where the practice would be so that you know which one goes with which. If not, I'll also put it in my Google Classroom. I might make a new Google Classroom, so if there's anybody who's not in my actual class during school, can also use it. Now, it's clear that I just made this one up randomly because I like to have more cancel. Do the x plus 3 and the x minus 3 cancel? They do not. We'll have some special cases later where 3 minus x and x minus 3 cancel in a unique way, but not ever if it's x plus 3 and x minus 3. Also, the x plus 3, my x minus 3 on the top cancels with the x minus 3 at the bottom, but this extra x minus 3, nothing happens to it, it just has to stay. So in the numerator, you get x plus 3, and in the denominator, you get x minus 3, x minus 1, and x plus 1. And that is the answer. So we were just practicing what if there's no 1 in the denominator. So I'm going to erase this right here. Well, I guess I shouldn't erase it, but remember, it wasn't there. And then you realize, wait, how can I flip something that's not a fraction? So that's where we put the over 1. Sounds good? So practice. This is called rational expressions, and you're specifically doing simplify, multiply, and divide.